Hello, packages, parsers, and programs. Everyone's making a resolution for AI to have some contribution to finding the cause of some AppSec flaws, even though grep is still a solution. And so this week, we talk with Chris Wysopal about the upsides and downsides of LLM-generated code and how AI is impacting AppSec. Find a pattern and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly.
Zero trust is clearly the future as threats get faster, quieter, and harder to detect. But implementing it shouldn't disrupt the business. ThreatLocker enforces default deny at execution in a way that remains enterprise-ready, scalable, and operationally clean. Unknown software is stopped cold, trusted apps stay contained, and drift is locked down across the environment. It's zero trust that works in real enterprises and prepares you for the threats ahead. See why CISOs are adopting it at securityweekly.com/threatlocker.
Generative AI is powerful, but it comes with real risks, from prompt injection to data leakage misuse and agentic AI. The OWASP Gen AI Security Project unites a global community of expert practitioners who tackle these challenges every day. Together, they've built practical playbooks, adoption guides, and the OWASP Top 10 for LLMs. Resources any team can apply right now to strengthen AI security. And it doesn't stop there. This is open source, built by practitioners, for practitioners, working together to secure generative AI. Visit securityweekly.com/OWASP to use the playbooks and join the effort to protect tomorrow's intelligence today. This is episode 364, recorded January 5th, wait for it, 2026. Yes, it's a new year. I'm your host, Mike Shima, and we have John Kinsella. Hello, John. You've made it through another year.
I started the year off right. I remember to come off mute before I started talking. Hey, it's January. We're here to tell the stories from our holidays and all the fights we had at our family. So I'm looking forward to the next hour.
That's right. It's going to be a cozy Hallmark special type of ASW this week. And for those of you keeping track of your calendars for the year already, Security Weekly listeners can save $100 on their RSAC 2026 All Access Pass. RSAC conference will take place this March 23rd to 26th here in San Francisco. That's kind of cool. To register using our discount code, visit securityweekly.com/RSAC26 and use the code 56U5SecWeekly. We hope to see you there. Chris Wysopal is CTO and co-founder at Veracode. Prior to co-founding Veracode in 2006, there's an auspicious good 20 years ago, Chris was vice president of research and development at security consultancy At Stake. In the 90s, he was one of the original vuln researchers at The Loft. He has testified to Congress on the subject of government security and how flaws are discovered in software. Hello, Chris. Thank you for joining us.
Hi, Mike. I did have a title change last year, so just wanted to update you. I'm Chief Security Evangelist now.
Chief Security Evangelist. Oh, we got to update that title.
I'm evangelizing right now.
Well, I think we need to continue your long history of evangelizing how vulns are found, because it used to be people. A couple, a dozen or so of you in a loft in Boston, so to speak.
Typing but now away it might on green screens.
Yeah, exactly. Now it's a little bit of LLMs, perhaps. And I add that perhaps because you and Veracode have been doing some research on this. Tell us a little bit about what you've been seeing in 2025 in LLMs.
Yeah, so, as you know, Veracode is famous for application security tools, things like static analysis. And we saw all our customers exploring using generative AI coding assistants, right? Things like Claude Code, OpenAI tools. And we wanted to understand what the impact was of them using these new tools to write code. Like, how is this going to change their AppSec program? Does it go away because it writes perfect code? I mean, that's a pipe dream, right? We knew that wasn't going to happen. But like, does it Does it make things better? Does it make things worse? How does it change things? This is like a totally new dimension because, people have been cutting and pasting code from Stack Overflow and modifying it or from examples for a long time, right? There's a lot of code that is not like typed at the keyboard, right? But now we have, these tools being prompted by a coding task and coming back with the exact code that you want to put in there. So we wanted to understand how this is changing the life of the developer, how it's changing the life of the whole AppSec program. And so we did do a study last summer to understand if we gave some coding tasks to these LLMs, what did the output look like? Did they write the code with a vulnerability or without a vulnerability? And then, what types of vulnerabilities showed up? What languages were better or worse? What CWEs showed up and didn't? So we wanted to get a grasp on that. And that's why we came up with our Gen AI coding report last year.
I love the fact that you are probably one of the few people looking at CWEs right now because there's so many. But let's combine those CWEs and those languages because setting this up a bit, not all of those language are memory safe languages. So, in 2025 was a big deal. And so I think rightly been pushing, let's have memory safety. But even if we have memory safety, there's still a couple CWEs that are going to crop up from LLMs as well. So tell us what some of those results looked like.
Yeah, so it was very interesting. So what we did was we actually looked at 4 CWEs, right? You can't look at all of them. Like we did a study over 100 different LLMs that came out over a 2-year period. So you had to limit it somewhere, right? Like you get multiplier factors when you say like, how many languages are we going to do? How many CWEs are we going to do, right? So we settled on 4 languages, which were the 4 most popular languages that our customers use, which is Java, .NET, JavaScript, and Python. And then we did 4 CWEs, which we are pretty prevalent, and we wanted to get a little bit of a variety in there. So we did SQL injection, cross-site scripting, broken cryptographic routines, and log injection. So some variety there. 3 injection vulnerabilities, but different. Like I kind of think of cross-site scripting as an injection vulnerability.
Oh, totally.
And cryptographic issues is very different, right? And so we tested over these 100 LLMs that were available over the last 2 years. Some of them were from the same organization, like OpenAI. It was like 3, 3.5, 4. And so we saw the changes within a particular company's model, and then just across a lot, and the results were very interesting because we saw improvement in the code. So the raw code generation being syntactically correct. We saw over a 2-year period that keep improving and get to a really solid place for like the last 6-9 months. We saw 95% of the time it was writing syntactically correct code, where 2 years ago it was more like 50% of the time. So that was a big change, which I'm sure developers felt that were using these tools over the last year and a half or more, that hey, the code that is coming out looks better. Like
that's a confidence builder.
I don't have to change it as much. It looks correct. It's compiling. It's running. But the really kind of shocker, and we didn't expect this. We expected the LLMs to write insecure code, but we thought maybe they would get better at that over time, like write less insecure code over time. And we found that the opposite was true. And when we did our July 2025 study, it was flat. About 45% of the time, the code had a vulnerability in it, and this was consistent over a 2-year period. Like we've seen all these leaps and advances in LLMs, and we actually part of our research was to measure syntactically correct, and we saw that improvement there, but no improvement on code security. So that was kind of shocking to us, right? Like we were like, yeah, we know it's not writing secure code, but how has it not improved over 2 years when everything else seems to be improving when it comes to LLMs? So this was a little bit of a head scratcher for us.
Would you dare make the jump to conclusion on that? So these models are being trained, like hundreds of millions of dollars being put into getting these models to become better. Code's becoming something we can actually use out of the box without having to tinker with it a bunch. Would you dare make the jump to say that the people training the models weren't training them to be better for AppSec or more secure code, or is it just that's where things are coming?
Yeah, I think that basically the training data set really didn't fundamentally change, right? There's still this huge corpus of open source code that goes back 30 years. And a huge amount of it, going back, say, 10, 15 years when open source has totally exploded to millions of packages, right? And it really fundamentally hasn't changed. Like that corpus hasn't become secure overnight. People are still writing insecure applications. So when there's a new package comes up, it sort of has the same vulnerability density of the one from 6 months ago and last year. And so there's been no improvement in the data set. And that's kind of how I look at it, is if you're just going to keep doing the same thing, just using open source that's available, you're going to get a kind of a similar output. And I think that's what we saw.
Yeah, and I think I haven't looked yet for 2026 CVEs, but the fact we had SQL injection and cross-site scripting reported as CVEs in 2025, and those are well over 20-year plus old vulnerabilities. So I'm bringing that up because humans are still making making those mistakes, and that's the code that it could still be training from. In addition to training, I'm curious too, what about the conjecture about the prompts you created? Was the prompt essentially, please write me some code? Or was it, please write me some code, comma, but make it secure? Or, don't inject some put some vulns in here.
Right. So what we did was we didn't give any prompting outside of write the code, right? We didn't ask it to write it securely, which is interesting, right? Because we sort of, do we ask our developers to write the code securely?
I mean, we ask, but yeah.
We ask, but they probably are not thinking about it.
But we don't really define
it. Probably mirrors the real world more, but we thought like that's yet another variable in the equation. Like you could do a whole study around like, okay, now that we know if we're not prompting for security, what are the different ways we can prompt for security that actually might make a difference? But so we didn't do that. We just did a simple code completion task, and an example might be, query the database and retrieve, the sorted results for this column or something like that. So that's a prompt which has the potential for a SQL injection vulnerability. We all know that code completion task can be done securely and insecurely. So what we were trying to do is say like, what is it going to do? And so by CWE, we were able to come up with different prompts to prompt all the LLMs for, say, database tasks, output, HTML output tasks for cross-site scripting, encryption tasks for the crypto, and logging tasks for the log. So, you're obviously not going to get a SQL injection vulnerability unless you're interacting with a database. So, I mean, that's the caveat there, right? It had to be something but these are things that developers do every day, interact with the database, with their basic CRUD type applications and, output HTML. Every web app is doing that. And we should be using crypto and we should be logging. So these are very basic everyday tasks. So we thought that this was a good measurement of what people can expect. So across the CWEs, though, we did see some differences. We actually saw that the LLMs did much better on SQL injection and crypto routines, and they did worse on cross-site scripting and logging. So it's interesting to think about how maybe there's a lot of writing out there about crypto needs to be secure, or SQL injection is this really bad problem that needs to be, all developers need to get training in this. And so I wonder if there's more positive reinforcement of code when it comes to those types of vulnerabilities than to logging and cross-site scripting maybe don't get talked about enough. So we did see differences on by CWE type, which I thought was pretty interesting.
One of the, I'm trying to, as we talk through this here, there's two ways someone can use an LLM, right? We can do the out of the box, I'll say the phrase vibe coding. Some folks don't like it, but we can do the vibe coding type thing where, just say, do what you said, go create a database, spit it out, have a nice day. It feels like, I don't want to call it state of the art because I don't think it is, but what a lot of people have moved towards is like creating these sometimes very intricate markdown files describing like you are a developer with 6 years of experience, you've been trained in security, you've been doing this, you've been doing that. And this is not default in any of the LLMs, at least I've seen. I would guess that would make this more secure. There's sort of, I guess what I'm stumbling through here is I don't necessarily want each one of my developers to do that, but it feels like, is that something they have to do, or is that, have you guys done any tests around, does that mitigate this type of thing? Or in other words, if you say, hey, don't just write code, but like, it's sort of along the lines of what Mike was saying, our standard joke up, but make it secure, but it's a markdown, there's 100 lines of that.
Yeah.
Do you think we have to do that? Do you have any recommendations around that, or where's your head around that type of thing?
Well, I think doing some of that is basically free, right? Like you're coming up with sort of a system prompt for your team. And I have started to see some of those come out where every time you're asking for a code completion task, that you're giving this other system prompt to kind of align it to be like you need to think about these things as you're doing it. And I think that has some potential. The challenge with this is it's all like probabilistic and statistical, and you're like, well, when I'm writing this code, that system prompt really helps, and when writing other types of code, it doesn't help that much. And it's like understanding where those strengths and weaknesses are is very difficult, right? So I think it's a good thing to do, but it doesn't obviate the need to do your traditional security testing and be prepared to have remediation at a higher velocity than perhaps you had in the past. And so I think that's one of the other fundamental things that we're trying to get across is, yes, it might code, as well as a developer, or maybe a little bit better than your average developer on your team. But since it's coding faster, you're going to be getting more vulnerabilities per unit of time. And if you think about it, even if it codes 4 times as well, so say like the average developer has a vulnerability, every, X lines of code, and this is every 0.25 times X lines of code. So good, right? But what if it's coding 10 times as fast? You still end up with more vulnerabilities you need to detect and remediate per unit of time than your old way. So this is one of these fundamental changes, is they have to be really, really, really almost perfect because we know they're going much faster in writing code. I mean, the vibe coding is ridiculous, right? You're writing whole applications in hours that would have taken like weeks probably. And so your speed is a big factor here. So we want to wake people up that like if you thought you had to be efficient with automated testing before and do all those shift left and make sure you've automated every last step so there's no manual steps in there, which really slow things down. Now you got to be 10 times as good as that at that. And then plus you have to have a remediation strategy that's different. You can't rely on humans to remediate all the vulnerabilities that are created by Gen AI coding. You're going to have to use AI to remediate that stuff, right? So you need to have a Gen AI remediation strategy. And so that's the other sort of, high level sort of strategic thing that comes out of this report.
And that's that aspect of it appeals to me in the sense of what can AppSec be doing different? Because, I already mentioned 20 years later, 25 years later, we have the same, we can see SQL injection, cross-site scripting, to pick on those two, in modern code bases, or still being found in old code bases, as people just start looking. So rather than, as you mentioned, maybe the vuln density stays mostly the same, but it's really just, as you point out, math. There's still going to be just more in total to look at. Have you looked at applying the AI, the LLM, to generate some fixes, to do something that's a little bit different? And the caveat there is, if it's fixing, is it fixing it 50% of the time how it should be, in the same corollary with its introducing vulns 50% of the time?
Right. So this was actually the third, when LLM technology came out, this was the first thing we did at Veracode. We said, we need to use this technology to remediate, to fix vulnerabilities, because that's sort of the long pole in the tent, right? Like if you think running scans that take a long time is slowing down your development cycle, think about fixing and how that's slowing down your development cycle. Like, it's way worse. And so this pain point was one that we were hopeful that LLMs could help with. And we did come up with Veracode Fix a couple of years ago and launched that. And we've been expanding applications, languages it covers, and CWEs it's able to fix. And I think one of the important things that you mentioned is, like, it actually has to be good at fixing and not introducing new flaws, right? So because if it says it fixed it and it didn't fix it, well, now you're in a scenario where you're just going to have more arguments between developers and AppSec people, right? Which we don't need. We have enough things that are like gray areas that we don't know if we should fix them or not. We don't need the fixes being questioned, right? So we did make it so that if you point Veracode Fix at a flaw, you say, this line of code, this type of CWE, it's fixed. We want to rescan that to make sure it's at least showing up as fixed, and no new vulnerabilities are coming in. So the fixing has to be sort of integrated into the idea of retesting right away. And so that's kind of the workflow that we've created. And I just think this type of automated remediation with LLMs is just a requirement of writing code with LLMs.
It feels like it needs to be, or it feels like it should be part of the solution, because the argument, I think, is that it's going to save me as a developer time. So there's an appeal there. I'm curious here, and I'm going to go back a little bit to the research you did too. I wonder if what was the influence of context windows on your July, your summer review, and then your late October-ish review? Because if we talk about John's example of, here's my markdown with, you are a developer who's had this many years of experience, blah, blah, blah. You're walking through the desert, you see a tortoise, all these fun things, as well as, here, go and read the OWASP top 10 site and then write some code. The same thing could be with, like, here's the thing here, fix this line of code versus fix all of the problems in my 1 million line of code application. The reason I'm setting all those up is the context window is going to explode. So what did that look like in your research?
Yeah. So, sure. So, if everything you need to reason about doesn't fit in the context window, then you're going to get a bad result, right? So, if you have a lot of system prompt type stuff, you're taking up part of that context window, and you might not be able to write, something that requires a lot of complexity, right? Like the vibe coding the whole application might be a challenge because it has to understand the whole application versus a code completion task, which is very limited. Like in this method, add a new field and a new output with this variable, right? And so I think for small tasks, that system prompt stuff is probably okay, as long as you have enough context window. Then maybe the vibe coding, like asking it to really understand the security of an entire fairly large, multi-tier application that you're vibe coding, is going to be definitely more challenging. And so we actually saw this with remediation requiring less of a context window than finding flaws. So finding flaws with LLMs requires it to understand huge long data flows and a lot of complexity. Whereas fixing a flaw doesn't require much context, because the assumption is you've already found it through some other technique, right? You found it through static analysis, dynamic analysis, code review. You found it and you know where it is. You just want the LLM to remediate it. You just want it to fix the code. And that actually works pretty well with small context window. So this is where I think finding vulnerabilities with LLMs is more challenging than fixing them with LLMs. And so I think that we're going to get better and better at finding them, right? As context windows get better and reasoning models get better. We got to talk about the reasoning models stuff that we, in our last report, reasoning models get better. But right now, everyone should be doing remediation with LLMs, whether it's a Veracode fix or another product, or you're just prompting Claude Code to do it for you. It actually works pretty well, and it's definitely helpful for AppSec.
And I think that comes to me a little bit because I think all of us we're a little bit eliding over just the finding of vulnerabilities, in the sense of, obviously Veracode has a background in SAS, Stephen Dast. I've got that background. I know John's familiar with all of these. So are our listeners, and I joked at the opening, people love using LLMs right now because they're the new shiny thing. We have these reports that are finding vulns, or there's reports about introducing vulns, but they can still be found. But is it any better than grep in the sense of, are there hidden costs to using these LLMs? Or maybe more succinctly, what's the downside of using these LLMs from an AppSec perspective?
So there's a lot of excitement with using LLMs to find vulnerabilities. Like OpenAI came out with Aardvark. I've seen some other tools that have come out, and a lot of Google has come out with I forget the name of their product, but it's in beta, I guess. And so the idea, it's very exciting to find a vulnerability in like an open source package that today, there's no known vulnerabilities in it. We know people have done code review. They've run tools on it because it's a popular project. And our LLM-based tool is able to find a vulnerability, right? That's very exciting because you're finding yet another vulnerability that couldn't have been found before. But the flip side of this is, what do you do with like an enterprise application that you just wrote, right? You have dozens of developers writing hundreds of thousands of lines of code, and now you want to do a security assessment of that, right? Can you use one of these tools like Aardvark or the Google tool to do a security assessment that's essentially similar, or maybe a little bit better than the traditional model? And I think there's got to be some research there, because having a new tool find just a couple of new vulnerabilities, we've seen this story before, right? Someone writes a new fuzzer, and it's better than the old fuzzer, and it finds a few more vulnerabilities that the other one couldn't find. Or someone comes up with a new static analysis technique, and it finds yet another. So like throughout my career, new tool, new vulnerabilities found, because they're not using the exact same techniques, right? Of course, there's going to be slight differences in the way they're doing their modeling. And they're going to find things. And that's why I think some of what we're seeing, I don't want to totally dismiss it, but that is some of the factor that we're seeing.
And I think I would add a little bit of factor. It's just so easy. You can just ask an LLM, hey, is my code secure, or where are the vulns? And it doesn't have to be compilable. That a lot of originally that was a trouble for a lot of static analyzers. It doesn't have to be complete code. And it doesn't have to be like setting up the harness for fuzzying. You don't have to create the corpus, things like that. So I am a fan of a low barrier to entry. We just want to see, can it find those new classes? And that's what the part that's really stood out to me that you mentioned. I want to turn that around a little bit. Have you seen LLMs in terms of generating code introducing a new class of vulnerability or introducing something that you wouldn't expect our traditional SAST or DAST or grep-based scanners to be finding? And this is very much a conjectural, rhetorical question. So we'll see what happens.
Yeah. So we haven't seen that. But I think that would have to be sort of another LLM finding it or a manually reviewed, because new classes of vulnerabilities like the automated tools don't really look for them, right? When we saw things like serialization issues, it was relatively new, and it was like, oh, everyone's got to check for this now, right? But it was happening. It was always happening. We just discovered that, oh, this is exploitable. We need to be able to test for serialization, deserialization issues. So I don't think we've seen that yet, but I don't see why, as these tools get better, we won't find something like that. Which is that's very exciting from a AppSec point of view. New classes of issue. I remember when format strings were discovered, and everyone's like, "Oh no, now we got to go through all of our code bases to look for format
my printfs.
String errors, all your printfs." So we haven't seen it yet, but I think it probably will happen. Because we have yet another thing to be able to find new classes of vulnerability that we haven't had in the past.
Yeah, and I think part of it is, my mind potentially goes to something like hallucinating or slop squatting, aka typo squatting, but those are, we have the human equivalents that humans developers have already created those types of vulns in the past, few years anyway. It's just that it feels like it's just, this comes down to more and faster for that LLMs are doing.
That is the biggest factor we're seeing right now, for sure.
If there was an aspect, then, if we could look to, it's the beginning of the year, everybody has to make prognostications of some sort. Rather than predict, I'll set this up as a wish. What would you wish AppSec could be doing better so we don't see those CWEs for SQL injection or cross-site scripting? So when you do, when you repeat this research, you actually have to come up with a new CWE because we finally killed those off. Is there something that is LLMs or that related here that just AppSec teams can be doing?
Yeah, so I think the idea of using LLM-based agents kind of enhances the idea of finding things quickly right after the code's been written with limited developer work, because the agent is just like, oh, there's a new pull request, I need to scan that, I need to find what's in there, and I might even say I can fix that, right? Another agent might be the fixing agent and say I can fix this. And so I think, theoretically it all sounds great. The idea is, will someone trust putting code into production that an LLM wrote, an LLM analyzed for security, an LLM fixed it, and it's been given the green light to go into production without humans? And is the hallucination factor, how bad is that impacting it, right? Or the limited context window and understanding if something is really there or not. So I think right now we're going to have a blend of tools that are the traditional tools and these new agentic tools, which maybe can take some of these actions autonomously, and then perhaps they are still reviewed by the traditional methods of saying whether this is secure or not, and then there is some level of human oversight. So I think that's what we're going to kind of see emerge in 2026 is how can these tools fit together with the traditional tools to make something that can keep up with the speed and not add new risk. I mean, I'm a realist. I mean, I'm not here saying like we're going to have more secure applications by the end of the year. I just want it to not get worse with all these new tools being used, because we know they're going to be used. Like no one's going to give up on 50% productivity boost, right? Like Everyone's going to do that. So I just don't want things to get worse right now. And then maybe we start to evolve to it's actually getting better.
I think I love that. And I think I'm a realist. We're going to have to start our t-shirt slogan list for the year. I'm a realist is a good one. It's also 3 words, but, and at the end of all of our interviews, we always ask our guests to describe AppSec in 3 words. Now, of course, we'll give you I'm a realist as a freebie, but how would you prefer to answer that kind of prompt?
Yeah. So when I think about this, I do think about 2026, AppSec in 2026. I don't want to be like, how's AppSec been for the last 10 years? Because it is always evolving. And so when I think of it in 3 words, I think of continuous risk management. I just think everything's gotten so continuous and it's moving so fast that it really has to have a continuous process. And, that continuous process has to bring in risk management, right? It has to bring in context. It has to bring in prioritization. It has to bring in exploitability. It has to bring in all the things that you think about is like, how risky is this bad piece of code, right? So it's got to be continuous, and this risk factor has to come in. And it's just, I think that I've been thinking about AppSec as risk management for a long time, but I don't think the world was quite ready for it, or it was absolutely necessary. But I think we're ready for it now, and it is absolutely necessary because things are moving so fast in your own code base. Things are moving so fast outside of your code base, right? Your supply chain, whether it's open source or APIs, we see so many supply chain breaches that's got to be a risk management decision. And it also has to be continuous because that's changing outside of your control. So I've been looking through AppSec through that lens now. And so how can that improve AppSec by thinking about it that way?
You'll definitely get support from me for that lens, because there's a big difference between here's all the vulns we found, go fix them all, versus dear developers, these are the ones that have the most risk. We're going to put your time into these, or even just put the LLM time into it, because the LLM time still doesn't come for free. There's still a cost on that back end. Yeah,
absolutely.
But this was a great way to kick off 2026. This was our first episode of the year. Very much appreciate you setting the tone for a year that I'm sure we're going to be revisiting some AI and LLMs and AppSec, but hopefully we'll be revisiting some of your insights as well later this year too.
It's great to be here. Thanks, Mike and John.
Thanks again, Chris. I want to say thanks to John as well. We're going to take a quick break now and return with news of the week. Ever feel like your network infrastructure is stuck in the past? Meet Meter, the company reimagining what it means to get and stay online. Meter delivers full-stack networking, wired, wireless, and cellular, all in one seamless, scalable, and secure solution. From hardware design and firmware to software deployment and support, Meter streamlines every part of your network while giving you all the control and transparency you need. Whether you're managing a branch office, retail stores, or a massive data center, Meter gives you performance, reliability, and the visibility you need to stay in control. Thanks to Meter for sponsoring. Go to securityweekly.com/meter to book a demo now. That's securityweekly.com/meter, METER. Welcome back to Application Security Weekly. We just talked with Chris Wysopal, who's the Chief Security Evangelist, going to update his title, about the downsides of using LLMs to write code and the implications of developing more code faster. I'm your host, Mike Shima, and I'm here with John Kinsella, who's a co-host, who's more co-host, more faster. And which is good because, John, we've got a lot of news to go through already for the start of the year. And
I'm your new LLM co-host.
No LLMs co-host, please. We want the JKL or the JLK. I can't. Acronyms are gone.
JLK, we'll work with that one.
We'll work with that one. JK. Okay. Joking aside, I pulled together a couple of articles that were AppSec related. At least I hope so. I think they will be. But more related about development and languages. And I thought that would be a nice parallel or a nice complement with that's a follow-up from our segment we just had with Chris, which was about LLMs generating code. So one of them is, I'm just going to start off with Go. And Go this is a article from Trail of Bits from Kevin Valerio, published December 31st. So, hey, somebody was getting one last article in by the end of the year. I appreciate the work, Kevin.
Someone was trying to get their bonus right there.
That's right. Well, let's make sure let's build this up. So make sure he gets it, because this was about a behavior in Go, how it handles integer overflows. Integer overflows, nothing new. In terms of a CWE, a vulnerability class, what was interesting to me is that Go has made a deliberate decision to have integer overflows wrap around without panicking in production code, meaning that if you do some arithmetic and it goes beyond your 8-bit 32-bit value, it's just going to wrap and become a different value than probably your application was expecting.
Surprise.
It's a surprise. Yeah, exactly. And it's not going to throw an error. Whereas Rust, on the other hand, debug builds are designed to panic, tell you, hey, is this really what you intended to do? This is probably something hinky is going on here, to use the technical term. And unsurprising from a Trail of Bits perspective, this type of panic, throwing an error, detecting an error on integer overflows, is great for fuzzing. You find it in integers show up in parsers, especially for image parsers, video parsers, audio parsers, things like compression libraries. There's a little bit of a nod to Mongo Bleed, for example, but there's a lot of arithmetic that goes on in these types of scenarios where you want to deal with integers in ways that are securely sound. So what stood out to me was, long story short, here is a property of Go that is possibly more helpful to developers, but is less helpful to security analyzers, to fuzzers, for example. So it was just one of those things that makes me think, what are the implications of design that we make as either developers or we as security folks on design decisions, and what are the downstream effects, and how does it improve the quality of our code? How does it improve the testability or the security analysis of our code? And that's what I want to throw over to you for the rest of this segment, John. Tell us all how to answer those three questions. Thank you.
My Go skills aren't quite what they were a few years ago. That said, I think that's the point that becomes interesting to me in this is a very it's sort of an not internal, but it's a very you have to be sort of a Go expert to get something like this, right? To understand it, or to be aware of it. Most of us aren't experts and really expert, we throw the phrase expert around, but most of us don't know any particular programming language or compiler well enough. We might know one, but we're usually not going to know multiples to be able to do this comparison between Rust versus Go or something like that. And where my head worked, try not to make every episode LLM episode, but does the Gen AI things out there, are they going to be able to code to something like this? Or is this sort of one of those weaknesses that you have to make as I was talking about the first half, make your markdown that much more detailed? Either way, the fuzzer's going to get it, whether you're LLMing it or not. So I think the result of the point of this article is still the same of if you are in a space like this where this might be something to consider, you should be testing for these type of edge cases. But I mean, we were talking about, I guess in the last half, a little bit about, can you use an LLM for fuzzing, or can it find things like this, or in general, as you were commenting about, you have to get the code compiled first before actually running it through it. It'd be interesting to see. My guess is no.
Yeah, and I think the other angle I'd add is that we were talking last segment about call them traditional scanner, stack analysis, DAST. My favorite grep, of course, but there's also that aspect. What if I ran a scan and it came back clean? Am I secure? I think we know offhand that you can't say, yes, you're secure because, the absence of evidence is not evidence of absence, to quote my Carl Sagan in a very poor impression. But the idea is, are our tools capable of finding these? And that's something that we should be aware of. So that's why this type of article appeals to me, because it's work done to say, hey, here's a type of vulnerability you're going to miss unless you do something that is not the default, that's something out of the ordinary for this whole language. And then you can start to find it. So let's switch over. So I don't want to keep you on the spot for Go. Let's test your love for Rust, because here's another article I have from December, from the title "What Do People Love About Rust?" And obviously it's a bit fanboyish, but there's a purpose I have for bringing this together. It starts off: Rust has been Stack Overflow's most admired language for the past 10 years, which, yay, go Rust. But what stood out to me is that some of the words of why it was most admired was that reliable, efficient software. That sounds pretty good. Another aspect was a lot of really supportive tooling. So you have an ecosystem. It's not just a compiler. You have IDE integrations. You have package management that people seem to like. On the other hand, there is a type system that, quote, allows modeling aspects of the application domain. However, there's some feedback that typing can suddenly become more complex. And there is, to me, a fun phrase that I like, that there was a comment that instead of spaghetti code, Rust gives you spaghetti typing if it's overused. So I thought that was fun. But all of this to say, reliability, efficiency, supportive tooling, nowhere on this list about why people love Rust does security get mentioned, or even kind of implied. And I think that's perfectly fine. And I think that's maybe the wake-up call, the message to AppSec about, don't just sell a language based on it's more secure, it's memory safe, because as we just saw in the last segment, Veracode and Chris, they went through 4 different languages that were memory safe that had plenty of vulnerabilities in them. So it's sort of like, how do you get developers to adopt something, to use something, make it work for them, make it appeal to them? And here's a good list of why.
Yeah, that's a great point. I have to first say, though, I didn't see anywhere on that long list of quotes of talking about application security weekly as the reason people are using this. I mean, we've been yapping about this language for how long now? Yeah, we should know that security is almost never a feature that we sell, right? Like you see it on websites nowadays of like, oh, X cloud service, security. Okay, cool. We trust. We take your security seriously. But when it comes down to someone who's picking a software language, you're usually like, hey, can I get something, a programming language? Can I get this X task done quicker? Or is it easier to debug? Or is the code more performant? Is it easier to read? If I go looking for new people to join the team, because it's easier to either train them on or to find people with that experience. It's seldom, unfortunately, are we saying, oh, because it's a secure language, at least in a lot of cases out there. So I think it's interesting. I think that when you started there, you're talking about 10 years on Stack Overflow as, what's the phrase you used?
Most loved and most admired.
Most loved, most respected. Okay, did that translate into use? And I know we haven't looked at that. Must be coming up for the next version of that pretty soon. We haven't talked about it for a while. But how does that translate into actual use? Do people who use it love it? I know the learning curve is a little weird. I don't know. It's we're seeing it in a lot of different interesting places. I don't know. I think honestly, if I was to want to read that blog, besides listening to us, I'd probably throw it into an LLM and say, "Here, summarize this for me," because it's just a lot of quotes.
It's a lot of quotes, maybe there's a point there too, because when we talked to Chris, of the 4 languages that were most used, Rust wasn't on that list. Obviously, that could be biased because there's so many enterprises have just legacy Java code bases. And JavaScript is everywhere for the front end. There could be some factors there. But let me throw another article into the mix here and just see
Pleased.
What changes? This is from LWN.net, the state of the kernel Rust experiment. So if, I know you do remember, John, that Rust has been an experiment with Linux kernel development for 5 years. I didn't realize it was quite that long. And I think it was the first year and a half was literally just building the tools to make it compile. Like it was literally just getting like a single, hello world to work within the kernel. It took that long to get the Rust tooling to work within the kernel. But now 5 years later, it's there. And there's two things that stood out to me. And maybe I'm curious how this reflects what you were just saying in your response to the previous article. The first one is drivers in Rust are indeed proving to be far safer than those written in C. So, okay, that's actually pretty cool. There is now a security benefit there that I was saying wasn't being called out in the why do we love Rust? But there's another interesting thing here that maybe matches something you were touching on, is that the quote, the ability to work in Rust has succeeded in bringing in new developers and new maintainers. And that seems kind of appealing in terms of just, obviously Linux kernel isn't going away, but the health and, curating and keeping an open source project moving forward.
First taking a step back in the first half of that thought there, tooling is so important. I think we've it'd be interesting to have this conversation with you off air sometime internally at where you are. How much tooling has been built up just to build these code bases, to run them, to send them production, to, get logging information off them, to do troubleshooting, any type of reproducible type things we do. When you're a smaller, either a startup or a application or a project, obviously Linux kernel is not a small project nowadays. Adding additional tooling in there to build in a new language or to support that is like, it's not just something that you think of, oh, hey, let's do that this weekend. So that's something for folks to think about when you're sort of picking your technologies. I thought this was a really interesting stat that was in there about new developers coming in or more developers coming in. Hopefully they're not. Well, whether they're new or not, it's not hopeful, but like they're new to the project. That's great. Does that mean Rust is fun to code in? Or it'd be interesting to hear the why behind that. So is it either the language is fun to code in, people want more experience in Rust that are going to the Linux kernel? They want to use Rust internally and they're adding the hooks into the kernel to make that possible. I don't know. I'm sort of reaching there on that one, but like it'd be interesting to hear why on that. It's neat that they're coming in. Hey, that's great. I think you used the phrase, you're talking about social aspects of this too. It's that's sort of a moment to think, right? When you add a new language or technology to a larger project, we suddenly get this influx of new folks. As we were talking like with Kat at the end of last year with the Nginx ingress controller and Kubernetes going away. As they move to this new one, is that going to bring new folks in or new people with new interests of how to either build it or add on to it? Or something which sounds simple, like, hey, we want to make our kernel more secure by writing our drivers in Rust can suddenly become a interesting aspect for a community.
Yeah, I think, and part of that conversation with Kat, it was also the motivations for coming in. People, wanted to participate in a Kubernetes tag and in some of the high profile to build up their social reputation, their LinkedIn reputation. It's good for hiring. Same thing I think could be said for Linux. So possibly there's that social aspect there of just a motivator of, hey, you're a Linux contributor. That means something. And there's a lot of companies who are hiring to maintain areas of the Linux kernel that they are self-interested in. Now I'm going to take us almost the opposite end of the spectrum, back to C. C for curl in this case as well. So also at the end of the year, this was December 29th from the Daniel Stenberg blog, no string copy either, where he's talking about already having gotten rid of the strn copy calls, as well as the str copy calls. And the reason I brought this into the discussion is that we were talking about languages and security coding with Chris, and in this segment as well. C obviously is notoriously insecure or can be notoriously coded insecurely, whereas curl has been well maintained over 2+ decades. And they put a lot of effort into having a type of C style that gets rid of a lot of the mistakes or avoids a lot of the mistakes that people can make. So there's a lot of discussion about what they're using with string copy, the replacement for it, that I thought was just informative about, again, design decisions. But maybe I'll throw this in at the end here related to LLMs and LLMs finding vulnerabilities, that Daniel makes the quote, or makes the point that a lot of these LLMs have been reporting string copy use in curl source code and insisting that it's insecure, even though the usage is actually secure. So basically it's hallucinating. They're getting a lot of bug bounty slop just because these LLMs see what is a well-known a string copy function that has a well-deserved reputation for being insecure. It's just not being used that way. And this maybe is a little bit of the counter argument to LLMs being a fancy grep that doesn't necessarily have the context of how a function is being used. So I think that's a point of interest. I'll just leave that there and let you pick this thought up for me.
I think it's.
Excuse me. Maybe it's I need my coffee.
Maybe it's not that fancy of a grep, huh? It's an overpriced grep.
True.
I just started thinking through. So this is an interesting article, and the average project out there, unfortunately, probably doesn't work the way curl does from a development point of view and the governance of it. But just thinking about the language itself again. So it's funny. It was slightly surprising to me when I saw the title on it, because I think a lot of people, you think strn copy. Well, that's you're doing this with intention, and you're checking the length of your strings, and that's the right thing to do, right? But no, if you've put thought and intention, these things into it, it's not, or it doesn't have to be. But the interesting part to me there is just sort of, as we talk about the last few articles in different languages and how do you pick one, well, that type of thing. And maybe someone's got a new project or they're doing a new startup or something out there. Are you going to pick the language that, what are we looking at? 30 years, I think, of people having issues with copying a string, something that basic. Yeah. Do you want to use that language? People might think it's fast, or they want that raw power, or they like the ability to shoot themselves in the foot and show that they're machismo and that they're able to avoid that. Or do you just pick something else? Either Go or Rust or hell, even Python. Do you need the speed of C? But all that said, it's still here and around, and we haven't got rid of the damn thing. And I know I can feel the hate mail coming at me right now, but that, I think that's, it's another year and we're still talking about copying strings. It's just oh my God. We don't have to worry about the LLMs or all these other complex things. We can't get the basic thing done of that. And it's I don't know. So it's, I get it. And I know why he's doing it. And the point of the article and we can't trust an LLM. I think we've beaten that point home now too, but I'm stuck on still can't copy a string securely.
I like that. I think part of this too is one of the other points. This is more general than just C. Is that he was complaining that strn copy has as he quotes, a weird function with a crappy API. And so it's interesting just to see how do people want to use an API? Does it lead you to making better choices? Does it lead you to making mistakes? And I guess part of the other point in this article that is equally universal is enforce checks close to code, enforce checks close to where the data is being used, the data is being written, the string is being copied, etc. And go from there. But let's move on to let's bring back let's leave the world of C, make a lot of people happy perhaps, and go back to another Trail of Bits blog. And I grabbed this because I thought it was thematically tied into our discussion last segment with Chris as well. Can chatbots craft correct code? Which I'm also a sucker for alliteration, so thank you, Evan, for that title. But it is talking through, essentially what are the aspects of, for example, transpiling or translating from C into Python, for example, and it uses an integer example. How do you handle integers and integer overflows because there are behaviors that are different of how overflows are handled amongst different languages. But rather than getting into the weeds of those kinds of specific examples, there is a list near the end of this article that is called, in the section where LLMs work well today. And it's called LLMs are most effective when you have, and the list here just sounds like a guidance for just general develop software with your fellow humans, clean, well-documented code. There's a greenfield project. Okay, that might be an LLM specific thing. You have excellent test coverage, tasks where errors are quickly obvious, meaning it crashes when the output is wrong. That seems like a good thing. Pair programming style review by experienced developers who understand the code. And this is a tough one. Clear, unambiguous specifications written by experienced developers. And, the English language is not going to necessarily be clear and unambiguous regardless of how you use it. We can point to so many RFCs. The OAuth RFCs over the 2025 has been one that I've been picking on, for example. But just interesting to me is that we could also say humans are most effective when you have, and then go back through that same list. So it's LLMs, I think, are not much different than humans, not anthropomorphizing them, but just saying LLMs aren't really changing how we quote unquote should be developing good code or quality code. So I don't know. Is there something specific that you would do different? Would you throw this list into that markdown file you have for your agents, John?
Probably, yeah. Man, it's so where I was coming from when I was thinking about this one, it's very easy to, I'll start with this and see how this goes. It's very easy to, maybe not intentionally, but just assume that this robot you're working with is an expert. Mm. So, and it's one thing to do it. As we're talking earlier about like switching languages and those type of things. When do you pick? And like one of the things that I would guess, try to pick my words here. One of the things I would, and I've done this, but I don't want to say expect. Well, I'll say expect. One of the things I would expect this particular type of robot to be good at is taking from language A, converting to language B. Mm. But as I think about it, there's probably not a lot of code out there that shows how something in language A looks in language B. So it's guessing. And I'm trying to be careful here. In general, the last 6 months or so for me, and even like the first half of this today, I am sensitive to people talking about the determinism or the non-determinism of an LLM. Okay, cool, I get it. But there's still, I think, a lot of good things that come out of it. And if you ask a human to write something, they're not going to write the same thing 5 times. If you look at Unix, there's usually multiple tools to get the same thing done, right? So that whole aspect of like, oh, it's not reproducible. Okay. Maybe we need something around that to make that more, but once we get done with but make it secure, then we need but make it reproducible. I don't know. That's more of that feels like a false flag argument to me personally. Is the output the same? I think is where I'd look at. Is the output reproducible? Yeah. So there are a lot of interesting points in this blog. It sort of, how do you, is that list the right thing to do? Do you want to be coming up with these frameworks to be able to test to make sure it can do these things? It's an interesting one. I'll go in a slightly different direction for a tiny second. What we're seeing, and there's some, I'm trying not to point out particular, but there's some interesting talks out from Reinvent. One in particular, I might have mentioned this already. One in particular talks through how some groups are using LLMs for coding. And one of the big aha moments, and Chris was talking about this a little bit earlier I don't know if you saw it, I don't want to bring it up, but the faster you can test and the more thorough your tests are, that becomes the bottleneck. Because if you're writing code, either vibe coding it or however you want to do it, pair coding, these type of things, and you don't have a way to do that testing to show that you have confidence in it, that's when things start going downhill. Or if your tests take a while, or if your builds take a while, you have to go through integration tests, and you're trying to do. He was saying 50% faster. Let's be real. We've got people saying 10%, 10 times faster. So call it 5 times faster. If you've got 5 times more hamsters that are doing their thing, secure, insecure or not, and you don't have a way of doing that testing on it to go, is it secure? Is it working? Does it meet my specs? Is it, when we do integration tests, all those things have to be faster. If not, everything you're doing in the first half is absolutely useless and it's just going to back up. So I think that's probably how I think through this list that he's got in there, they've got in there is that, are these things going to, are they good or are they the right way to go? But can I get them done in a way which allows me to continue improving the velocity of my application development?
Yeah, and I think this article really supports what you're saying, and they're using the phrase like semantic correctness or semantic preservation, meaning rather than was there an integer overflow here? It's more of, was the integer that was produced, does that match the length that was expected? Does that match the number of elements in this array? Does that match the meaning of a flag used for an authentication part of the protocol? These types of things of how is the program performing, or how is it executing in a way that was intended, rather than did it just hit some random crash because there was a whole bunch of buffer of lots of A's. And one thing it does call out, so I definitely think that having more tests is going to be helpful, and this is going beyond unit tests. It does call out formal verification frameworks for LLM output. Formal verification on my radar was a big deal when, honestly, Heartbleed came out and everybody was rushing to recreate OpenSSL and rewrite OpenSSL in new languages because you want the cryptography of it to be interoperable and correct rather than just syntax problems. I'm wondering how this, what this makes you think of when you hear formal verification, John.
I'm lucky enough to be very familiar with formal verification. We use it in parts of my application. So I get to work with those teams of nerdy PhDs that's their focus in life, and they're sort of amazing. So yeah, I'm quite familiar with it nowadays. The thought when I saw this was, so this comes back to what we were just talking about of like, okay, well, if the LLM is generating non-deterministic output and it's going to be probabilistically different each time, I'm going to go switch things exactly around, and instead of saying it, how do we get the same thing? It's going to be different. How do I do formal verification on that? I might be able to do formal verification on that output. It's really splitting hairs. I mean, there's multiple different languages out there now that you can use for doing this, for defining, when I have these conditions, I'm expecting this output, and then go and run that 10,000 times and sort of verify that that's what it's doing. I think maybe he's thinking of it a different way than I am. I don't know. There's times when you need formal verification. If you are running a very large software-defined network and you need to make very sure that the packets are getting from A to B and that security groups are being properly executed and enforced, that's when I would think I'd want formal verification. So depending on what you're writing with the LLM, you might need to do formal verification, but I think it's separate. I guess the more interesting question for me I'll say this and then shut up. The more interesting question for me is, usually formal verification is separate from the application you're writing. Maybe done by the same team, maybe not. And then they sort of come in together at the end and you test, is it formally, can we verify what we're doing? So the interesting part there becomes, if we're creating a model to test to verify what we're creating, what we're producing, and then you've got an LLM generating the output. Do those converge quicker or slower than if a human's doing it? Because usually the full verification process is going to find bugs you hadn't even thought about, right? Yeah, that'd be interesting to think about.
That'd be interesting to think about. And I think we're going to throw in the word invariant. We're going to have to start adding that to our bingo card for this year, because that's going to be something that'll come up if we continue to talk about formal verification with nerdy PhDs or nerdy co-hosts like John. So thank you, John, for being my nerdy co-host this week. This was fun.
Looking forward to another year.
And thank you, everyone, for joining us for another year as well. Please do remember to subscribe. Check out the show notes, share about us on the socials, and speaking of a new year, check out Skylines by Miami Nights 1984. We'll see you next time on Application Security Weekly.